again, the debate question isn't the leaderboard anymore. It's whether open base plus a fine-tuning platform can beat the closed model or other model strategy, right?
All that and more on today's Mixture of Experts. I'm Tim Hwang, and welcome to Mixture of Experts. Each week, MOE brings together the best banter in artificial intelligence to walk you through the welter of this week's news. On this week's episode, we've got Aaron Baughman, IBM Fellow, Merve Unuvar, Director, Agentic Middleware and Applications, and Chris Hay, Distinguished Engineer. Welcome to you all. 4 big stories today. As always, we're going to cover Muse Spark, GPT 5.6 Sol's performance against Arc AGI 3, and this really odd paper out of Anthropic about the J space. But first, I really want to start by talking about thinking machines. So this is the kind of hotly talked about, anticipated lab from former OpenAI CTO Mira Murati. And this is a lab that's kind of floated around for a while. They've done some blog posts, some research paper releases, but just this week they have launched their first model, a model they call Inkling. It's a 975B total parameter model, but it's a mixture of experts, so 41B active. This is really interesting. So it's the first real release from the lab, kind of manifesting their approach to some of the contemporary problems around model training and model pre-training and their sort of philosophy for going about doing this. Interestingly, it's an open source model. And I guess maybe, Chris, I'll kick it over to you first. I know you're the most excited to talk about this. What's your take? I mean, one of the most interesting things about this, in my mind, is they're quite straightforwardly saying that this is not the top model from a benchmarking standpoint. What do you read into that, if anything?
I love it. It's like the English model. It's like, it's okay. You know what I mean? You know what I mean? I think it's
model.
Cool. Yeah, exactly. I don't think in this market you need to be the best in the world. I actually think they needed to get a model out. Well, that's the biggest thing they were lacking, and they've did it. And I love it, actually. It's not, as you say, it's not the greatest model in the world. The frontier labs are all better than it. All of the Chinese models, GLM, etc., they're all better than that. So, but here we have a great open weight model from a US lab. Awesome. And there's actually, there's some really nice architectural things in there, which I really like the direction. They're heavily influenced by the DeepSeek models, which I think is great. But their approach to multimodal is a little bit different as well. So I definitely appreciate that. So if you think of the other multimodal models that we've seen, it is like what's the best way of saying it? It's like melding a bunch of different models together, right? Here's a vision encoder, here's an audio decoder, I'm gonna go mix it together, and then you go, yeah, no, it's one model. Honestly, it's one model. Don't look under the hood. Please don't look under the hood. But actually, they've actually went truly multimodal, and they're really sort of taking it down to token level, and they're taking a small sort of pixels, I think it's 40 by 40, project it on, and then it's down into tokens. So it's actually true multimodal, and I appreciate that. And then I like their approach to speed as well. So there's sort of taken a bit of a fast path. So it is quite a fast model in that sense. I'm not going to go into the technical details of it, but they've made interesting architectural choices. It's not the same model as every other model. So I applaud them. I played with it. It's pretty good. I'm waiting for the great version. And yeah, I'm excited.
Yeah, Merve, I think, to what Chris is saying, it does kind of feel like thinking machines is almost trying to change the competition in a little ways, right? Like that, like usually what we'd say is it the top benchmark? Okay, then it's the best model and we should all use it. Here, they seem to like just say, yeah, there's a benchmark, but here's all this other stuff you should care about. And, it certainly sounds like Chris has kind of bought that story, right? Which is natively multimodal and kind of all these interesting architectural things that we're doing. Do you think that's going to shift the market? Like, do you feel like this is where things are going, where, benchmarks really are just not going to be the thing that people care about as much anymore?
Yeah, I believe so. And I think like they're different approach here, like more than, of course, like whatever, the advancements they've done and differences in the architecture and the model, as Chris said. But I'm impressed by this like a fine-tuning platform that they built, right? Like you basically, like you don't give a prompt, but you say like, I don't know, the example that I read was like writing using no letter E, and it drafted the plan, generated its own eval and synthetic data, ran the post-training through their Thinker API, loaded the new weights back into its coding harness, and answered correctly. So this is like a full closed loop, right? Like that, the no E that is you make, but the orchestration is the point here, right? Like they can do this fully automatically. And I think going back to the competition here, as you said, like they state Inkling is not the strongest model available, open or closed. I think the whole pitch here or the differentiator, best open base to customize for your needs, right? Like the multimodal, efficient thinking, fine-tunable on Tinker. So again, the debate question isn't the leaderboard anymore. It's better open base plus a fine-tuning platform can beat the closest closed model or other model strategy, right? I think it's worth the try, and we'll see how it plays out in the market.
Aaron, maybe we can kind of zoom out a little bit in this discussion. I think this is a caricature, right? But I think the discourse for some time has been like, America is really good at the closed source proprietary models, OpenAI, Anthropic. And when it comes to open source, we're okay, but like what we really look to is like places like DeepSeek and, these kind of Chinese labs that are really advancing the state of the open source. I think this is notable in some sense because it's kind of like this, kind of widely watched US frontier lab using open source first, as part of its release. And I guess, Aaron, maybe a question for you is like, maybe do you think we've been thinking about this all wrong? Like that actually just turns out that like actually America can do open source super, super well as well. And we can do fundamental things there, same way as a DeepSeek. I guess kind of how you weigh that up. Maybe we've just been mistaken, all this time.
Yeah, I think with Inkling, the real headline here is customizable intelligence that's been open sourced, right? Because really, the future of AI, it might not be about building the biggest model. That in turn is a frontier model that could be closed source, but it's about giving people the ability to customize, adapt, and control these types of models for their own needs, right? And I noticed that, within this chain of, what is the Inkling? What's the difference? Why does it matter? And then does it really matter that it's not the biggest, most powerful model? I don't think it does at this point, because, there's many layers, right, to this. You have this general intelligence layer that's a pre-trained model on broad capabilities, but then you have this customization through fine tuning, right? So these different ways of PEFT, the parameter efficient fine tuning capabilities of LoRa, for example, right? Then you go down to being able to use RAG to, get the data, the fine tune, right? Then you can also customize, behavior control and the way of which it's going to think through the prompt itself. You can customize agents and customize through these different types of feedbacks, right? But this way of having Inkling with this self-improving method so that it's really customizable towards your own needs, I think is key. And even better, right, is that it is open weight, because this is a bit of a different spin about, what all of the main competitors, right, are doing. Such as, Sold, you've got Fable, you've got, Gemini Pro, for example. And then I think underneath that is where Inkling sits. But I don't think Inkling right now is trying to compete, right, with those big models that are very deep, right? But it's a smaller type model. When I say small, from what I could find, right, it was about 975 billion parameters. So it's still a pretty big
Yeah, these
model.
are giant models still. So.
The measuring stick has changed, so much, because I remember many years ago, 100,000 models and parameters was big, but now we're at sets 975 that are now open source, open weight with 1 million token context window that can handle multimodal input. But again, let me circle back to what the headline here. It's customizable intelligence that's now been available, made through these open weights. So I'm excited about it, and I do think Inkling has a place.
I think one of the things is if we go back, what was it, about a year ago, maybe it's just less than a year ago, where they did their first blog posting and everybody's like, what's Thinking Machine's going to say? And it was like, oh, here is how to do determinism, right? We have managed to control the batch, so it's all reproducible. And we're like, Boo! We want to see a big model from you
Lame
people.
research.
We don't want to see this. And then, but actually, if we fast forward now, actually, the very things and principles that they put in from the beginning, the fact that they do have determinism across their batch sizes and reproducibility, I suspect that's what's going to allow them to move from we're not quite at the frontier level yet. But oh my goodness, I think they've got that control experimentation-wise to be able to move past that very, very quickly. And again, you can kind of see it in the architectural choices. They've dropped rope. They've got, the fast lane for the sliding context windows, etc. So they're taking an awful lot of optimizations. And the only way you can take those optimizations is through measurement and reproducibility. So they're not just sitting there going, "Hey, I'm the Swedish chef." It was like, "Hurdy-gurdy-gurdy," and then put the ingredients in, and we got the model. They're doing proper controlled experiments, and the fact that they're at this point here, I'm an optimist. I think maybe a few months' time we're going to start to see a really competitive model because I think they're taking the right approach.
Well, that's actually a great transition to our next segment. We've talked a little bit about thinking labs, which is maybe a lab that's kind of competing different. We should now talk about a lab that I think is like kind of competing same in some sense. Meta, after being quiet for some time but creating a lot of noise in terms of its recruiting and the money it's pouring in, is out with its first statement of the kinds of models it wants to release. Muse Spark 1.1, which is the latest model from the sort of so-called Meta Superintelligence Lab. This is in contrast in some ways to the Inkling launch, a very different kind of model launch, right? I guess, Marvin, to your point earlier, it shows all the charts, and the end result of all the charts is that they're killing it on the benchmarks, and they are better than, all these other proprietary models, OpenAI and Anthropic. And I guess question for you is, Marvin, do you read these results as saying that Meta is now sort of once again a serious contender in the space? Because it feels like we have not talked about them for quite a while. I feel like Llama was the last time they were really capturing the narrative. And this might be a chance for them to maybe get back into the game. Do you think this is kind of a credible foot forward?
No, I think it is. Like after that rough Llama stretch, I think coming back with this model, especially, I think aiming where the market is going, right? Like the agents, not chat, multi-agent orchestration. I think they emphasize the planning and then the delegating, the parallel sub-agents to cut latency. Computer use, for example, is a popular use case across multiple apps that is gonna make them stand out. And I think the interesting fact is like the million token context it actively manages and compacts. Like that's also a strong feature that they packed into this. And I think they also have a strong coding harnesses in this release. So this is like as you said, like after Llama open weights, leading the open, model era for a long time, right? Now we have a coherent opinionated bet. Like they want to be the other highlight is like the cost efficiency, right? Like they're cheap and fast, long context engine, so you can run agent workloads on scale. So they're also going after the enterprise use cases here. So it may not be the smartest. I know the benchmark's leading, but I think the most economical one to build agents on. And I think this could be their catch and to build success on.
Aaron, it's a little bit odd in light of kind of what Marve is saying, is that like it does seem like where you would go with a model like this is to start offering kind of enterprise AI services. And I guess we don't normally think about Meta in these terms, right? The creator of Facebook, the owner of Instagram, WhatsApp, these are by and large consumer tools, right? And so it's kind of interesting that like the suggestion here that's kind of reading between the lines is, does Meta believe that they're going to become an enterprise kind of B2B SaaS type of operation? Is that even something that you think is possible?
Right. I mean, if you start to organize all the different players, about what have they contributed to the Gen AI field, the way I look at it is that OpenAI somewhat proved AI could think. Now, let's put that in quotes, right? We'll talk about that in a bit. And Google proved that AI could scale, right? And now I think what Meta's doing is they're betting and showing that the winner will be the company that puts this intelligence everywhere where the people are, right? And so that connects the dots to all of their social media platforms that they already have. So it's pretty exciting to see, what they're going to do, because this is their biggest strength. They have a large user reach, hundreds of millions of people on this platform. You already mentioned WhatsApp, Facebook, and so on, but they also have, somewhat of a nice hardware ecosystem. I was just playing around with their Ray-Ban smart glasses. It's fun, um, but if you could get this model linked up into it, it'd be very powerful. They have the research talent, right? They're a long leader in AI. We talked a bit about the Llama models, but don't forget about PyTorch, right? Even back in the day with deep learning libraries, if people are still, which they are, building their own neural networks, which in turn are building blocks for these Gen AI pieces, they contributed that. And then they also have an open plus a proprietary strategy, which we're seeing emerge, right? Open, they've been very, very good at that. And now this proprietary with Muse Spark, I think, is where they're starting to a tick. This model does have a little ways to go. I looked a little bit at the benchmarks and noticed that on the ARC, the AGI, piece, it's a bit weaker, right, than the competitors, right now at least. So it's not quite up there at the frontier capability, for that particular type of test. It is great at these knowledge-based kind of tests, right? Where if you look at the artificial analysis index, for example, GPQA Diamond, right? So there's a whole suite, and it does very, very well, and it puts it up in the upper echelon. But I think where the field is going, it needs to jump up a little bit, right? And we'll talk a bit about Soul and what all this means, right, coming up.
Chris, the other thing I want to kind of investigate on this story was, we've been talking a little bit about how like the meta strategy of launching models is changing, particularly with Fable and Mythos, and kind of how OpenAI approached their model, where they said, okay, well, only some certain people are going to get access to it, and then we're going to more broadly distribute it. In some ways, like I feel like the Spark release here is like kind of a throwback, and by throwback I mean like to a few months ago, where no problem, we're going to just make the model kind of like openly available, and part of it is to kind of like push distribution versus being really, really kind of constrained about who accesses it early on. I guess, I don't know, do you think like Meta is eventually going to go the way of the other big kind of frontier model companies in this respect, or is it kind of still open, like that they're going to keep kind of leading the way in terms of like shipping and launching without a whole lot of restrictions on initial launch?
In order to get restrictions, your model needs to be good enough, first of all. Once you get there, we can have that conversation. And to Aaron's point, it's not there. And I have to say, and I kind of feel this is kind of like a meh release, and I love Meta, right? I love the Llama models. I thought they were a lot of fun. They were releasing things that were open way. They sparked a whole community to get started, right? And you could argue that was really the Mistral guys, and they went off and created Mistral, but here's a closed model that powers social media, and you can use the APIs. And look, it's better than 4.6 Opus. Yeah, we all know it's not better than 4.6 Opus. You should be comparing it at least to 4.8, if not Fable, Mythos. But you're comparing it to 4.6, and I just don't buy that it's better than 4.6, because everybody goes, oh, it's better than Claude in this, and it never is. It never is. So am I gonna go and spend money on it? No. You know what they should have done? They should have released it as an open weight model, and then we'd have been like, woohoo, well done, Meta, yeah. But no, now I'm gone, thinking machines, etc. That's what they needed to do. I understand why they're not doing that, but it's like, do I care about a closed model that's worse than the great models? No, I just don't care. You know what I mean? It's like, so there we go.
And Chris,
tell
it's
us how
funny
you really
that
feel. Marva, yeah, sorry, go ahead.
I just want to say, like, I noticed throughout the release note, they kept using like competitive with leading alternatives, or like competitive with like today's leading frontier models. Like nobody writes competitive with when they beat everyone, right? Like you write the numbers.
Competitive.
So,
You're like,
I know, yeah.
All right. Well, Zuck, if you're listening to this, you should work harder to impress Chris Hay. He'll be on it for the next round.
I want to like their model. I like Meta. I know I'm one of the few people that like Meta. I like Llama models, etc. I just want you to open it up, or But if you turn, Merve, to your point, if they were like, this is 20 times better than Fable, I'd be like, let me add this model. I want to play with it. But it's not. It's like, this is like the Honda of models. And you're like, great, I don't want to drive a Honda. I want to drive a Ferrari. Do you know what I mean?
Yeah.
Well, that's probably going to be the last word on this one. We'll move us on to our next topic here. So the next story I want to cover is pertaining to a benchmark called ArcAGI that we've talked about before here on MOE. When it was originally released, it was sort of slated to be like the hardest challenge ever for AI to solve. And really the kind of core idea of the benchmark is, can models learn entirely new skills, without, further kind of like prompting or frameworks or kind of like being guided along to solve the solution. And we've seen more and more progress on it. But this week, it was once again in the news because OpenAI's GPT 5.6 Sol, one of their latest releases, really showed this big jump in progress where, you look at sort of Luna and Terra, and they're scoring low like many of the other kind of like models. But then with Sol, you actually see this jump, right, where, it goes from 0% basically to 8%. Which, given the difficulty of the benchmark, has people sort of chattering. And I guess maybe, Marve, I'll kick it over to you first. How should we read these results? 0 to 8% maybe doesn't sound like a whole lot, but in contrast, if you look at the benchmark, it does seem something that's really difficult for AIs to do. And so
I know.
I guess, how do you handicap this? Is this an impressive result, or, I guess if you want to be the Chris of this segment, maybe this is like a boring result.
I don't think it's boring, but I don't think we're no way near AGI yet, right? So every time the field saturates, on one of these, the ARC release is a harder one targeting like what the models still can't do, right? And a 12-year-old kid can do, right? So, and then the scores collapses again, like 8% versus, a human that can do like 100% is not true AGI. And I don't think the score is what's going to convince us when we get to an AGI. Like the day when someone releases a new benchmark full of tasks that are easy for people, and none of these models just, or the frontier models just handles it out of the gate, right? No specialized push, no, work at front. And then I think this AGI will be here. So, but I think it's a good progress. If we look at the ArcAGI 2, it was up until 92%, I think, like a very high percent. So it can come up there too, but we're nowhere near, I think, full AGI yet.
Yeah, I mean, this is one of the hilarious parts about it. I buried the lead a little bit, which is that this is performance against ArcAGI 3. And, in some ways, when this benchmark was first released, they were like, once you pass this will definitely be AGI. It like saturated. And now they've just been in this game where they keep having to launch new benchmarks to be like, it's not AGI just yet. And I guess, Aaron, I mean, do you think we're going to see the same thing with ArcAGI 3, which is, this is like, it's like a boat with a hole in it. Like the water keeps coming in and you just can't keep ahead. Like anything you think is too difficult for a computer, it ends up appearing to be able to do in much less time than you think.
Yeah, I mean, throw me some more buckets so I can keep getting that water out of the canoe, right? I'm getting more and more holes. But yeah, I mean, Sol is not AGI, right? But it is one of the clear signals that the gap, I think, between today's frontier models and something we would recognize as AGI is beginning to shrink. From like the fundamental limitations that we have now towards, not yet, but towards, an engineering and scaling problem. And I think that's indicative of the ArcAGI 3 results, popping up to roughly 8%, so that is pretty impressive, because AGI is all about, having an AI system that can perform on a whole range of intellectual tasks that humans can perform, rather than just being specialized just in one particular domain. And I think what this is showing, right, is that Sol is beginning to be able to reason within a world of uncertainty that maybe it hadn't seen, but it's this unfamiliar environment, that it's had. And I mean, it was released not that long ago, right? So, I know that they've used, megawatts of power, maybe 10,000 houses worth of power to train this type of model. But I mean, I think it's only going to get better, right? And it is great, whenever you look at the benchmarks at AGI 1 and 2, the ARC sets that did really, really well. And then on 3, it's beginning to sort of look underneath the water at that iceberg, and begin to explore that space that it ordinarily couldn't have seen. So yeah, I think over time, that arc, right? It does. First of all, we need to make sure Arc AGI 3 is the right benchmark that we want to march all of our models to, right? And then look at other benchmarks and sort of decorate that, so that we can define what AGI is as a group and a community, and then begin to get these models marching towards where we ultimately hope that they can go. At least some of us hope they can go, and in a responsible way. But let's also think about, um, you know, it's a trade, the amount of power, right? Because I was stunned. I was reading about this, that even on inference, typically, whenever you're starting to get into the class and the neighborhood of AGI, but inference costs about 60 homes worth of power, right? Just to run that type of job. So it's pretty incredible, just the power that all of these use, so that we can begin to have a model that's somewhat going upwards on the trend of being able to solve 8% solving the Arc AGI 3.
We got to do better than that. I mean, I get your point. We maybe moved up to 8%, but I think $19,000 to solve that particular task. I think there is some architectural changes that will need to happen to hit that number, in my opinion. So it's great to see the number going up, but is the dollar value going up at the same time? That's a bigger question.
Maybe a final thought on this, and would be curious if anyone has any thoughts on this question. Is I guess are we just already at AGI? There's like another position here, which is that we keep trying to come up with tasks that are harder and harder and harder. But it is true that, like, if you just, thought back to where we were 3 years ago, and you thought about what the models can do today, you would have said, yeah, okay, that's AGI. We're there, right? Like, we have a model that can just do these incredible things for most of the tasks that you ask them to do. They can do it. And in fact, now we're in the situation where we kind of have to keep coming up with more things that it can't do to kind of hold this line. I don't know. Do people agree with that? It's like, maybe we're just actually already at AGI. We've actually been at AGI for some time.
I think I already said at the beginning, I don't believe so. I think the day when, we release these new benchmarks and the model just does out of the box great, that's the day I think we can claim we're getting to AGI. Because every time, when you release a more difficult or a little bit different benchmark, it's very embarrassing to Chris's Spark, 8%. I mean, something, but come on, if a 12-year-old can do 100% and if a model does 8%, this is definitely not a
right. It has to at least be the 12-year-old.
Exactly.
Yeah.
Yeah. I always look at, humans and their growth, into an adult. And so I think maybe we're at a infant level AGI, right? Right. Maybe we're trying to get to a 1-year-old AGI, but we have a long ways to go to get these models into adulthood AGI, but because fundamentally we're still trying to define what does AGI actually mean. And I just always say that it's the full range of intellectual tasks that humans can perform. But then you ask yourself, so what age group, how are we going to stratify a human's capability and measure it? Because yeah, we could fulfill that definition if we're looking at, a 1-week-old baby that is born, right? Because that is a human being. Right. So, so it's just a matter of where your measuring stick is going to be. Right. And then I think all of these benchmarks that we're creating is then tagged, to what a human capability is. But on the other hand, I think we're also trying to surpass human capability, because humans can't look at hyperspectral bands, but we have all of these different instrumentation and tools to go out and view the world and then pull in data that humans can't sense. Right. And so it also, I think there's an AGI that goes beyond, what humans can do. So I think bottom line, it just depends on how you define what AGI is and how does AGI map to your organization's business goals of which they want to track to.
All right, last topic for today. This was an interesting Anthropic study that I wanted to quickly touch on before we close the episode today. And I guess I'll read the tweet where they announced it because this created a bunch of controversy when it came out. Anthropic writes, "Of everything happening in your brain right now, only a tiny fraction is consciously accessible. Thoughts you can describe, hold in mind, and reason with. we found a strikingly similar divide inside Claude. And the paper goes on to describe what they dub kind of the Jacobin space or the J space. And so the claim of the paper is basically that there are sort of regions within the model that do reasoning and processing that aren't sort of explicit outputs. And so Anthropic looks at this and says, well, there's actually really this kind of interesting structure between sort of the conscious, outputs of the model and all of the processing that it does that is kind of like sublingual or subconscious, maybe. And so this created a bunch of controversy, right? I think, some people took a look at this and they said, you guys are reading way too much into what you're discovering here. It's interesting, but it's definitely not, the AI has a subconscious. And I kind of want to bring this to the panel because I read the paper and I was kind of like, I don't know, I can kind of see it both ways. Chris, maybe I'll start with you. I mean, do you buy kind of maybe the frame that Anthropic is bringing to some of the results that they have here? And how much of it is kind of poetry, elaboration, and how much of it is like a real true way of understanding what's going on in these systems?
I think all of the above. I hate to say it. So,
Good answer.
so I mean, the first thing is I think the J space is a good breakthrough, right? Because if we think about how we would look under the hood, we'll ignore chain of thought for a second, right? But the techniques you would tend to use is things like logit lens. So you would look at the various layers, and then you would be able to look in and then see the top tokens, and you can kind of project the activations against the tokens, and you could see roughly this aligns to this text. And what they're doing in this particular case is they've got a new technique, which is kind of similar to that, where they look at the activations, to do some averaging, etc., and then they can say this is roughly within this space, and they can roughly say, well, if we average this out here, it's thinking about deceit, is thinking about whatever, right? And I think I think they have a better technique there. And they're absolutely spot on, right? Which is there is the final output, which is your token output that you see. But there's a whole lot of, I'm going to avoid the word thinking, but there's a whole lot of calculations that happen underneath there. And what they're doing is lighting that up. But the big thing here they're doing is not projecting that into token space, right? They're using this Jacobian technique. So, and that gives you an idea what's thinking about there. So I think that's really interesting. And we kind of see that. So it's everything that's going on before it sort of projects down into a token. So would I call it consciousness though? I mean they avoided saying that themselves. I would say
They're strongly implying it, I think.
I mean, they're smarter than me, so they've got the Claude model. Maybe if you Anthropic, if you want to send the Claude model across to me, I'll take a look at it. I'll even agree with you if it's conscious, but you need to give me the weights, my friend, to play with. So I think, the answer is I don't know. I'm definitely not smart enough to do that, but I think the technique is great, and I think they're shining lights on the darker space that is below that projections to be able to see what's going on. So I think all of that is goodness, and I think the outputs that they're getting from this is great. I think probably the most interesting part of the paper, and I've done a lot of experiments in this area myself, but I think the most interesting part of the paper for me is the fact that they see the chain of thought whenever the chain of thought is used as a scratch pad, etc., to basically say this plus y, blah 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 blah. But actually, one of the things they're seeing is when you kind of take away the chain of thought elements, or rather, there was thinking that was going on in the J space where you introduce a chain of thought, it then ends up on your chain of thought, and it's no longer sitting in the J space. And I think that's interesting because it's kind of showing the model scratch pad is like its internal thought versus writing it down onto a piece of paper and then offloading that. Now we kind of know that sort of exists beforehand, because if you play with the model there and you think about next, and this is really the crux of things like distillation, when you do a token, and Anthropic's done previous papers on this before, when you do your next token prediction, there's enough hints on the previous token and fingerprints in that sense that leads you into what the next token is as well. So they all exist. I think it's great. I'm just not in the whole conscious thing, you know. But I mean, good luck to them. But I mean, awesome piece of work, really is.
Yeah, consciousness is a big word. Aaron, what do you think? Are you an all of the above kind of guy like Chris here, or are you more skeptical?
Yeah, I mean, I think so, right? I think there's a lot of overhype here, right? I mean, just the headlines of the paper, right? I mean, the overhype elements seem to be, Claude has subconsciousness, or the model's thinking, or now we understand how LLMs work. But I think what this paper is on par for is that we can see inside the model. It appears that really what this work is about is almost like building. You could think of like an fMRI, to see the pathways, what's really happening within these deep neural networks that have been constructed and trained. But it's not really about that. This is AGI. This is conscious, right? Right. I think that's very misleading, right? And if you can cut through, all that fluff and really get into what the contribution of this work is, then it's really these things that they call attribution graphs, right? Where you can identify all of these meaningful features that are happening. You can test different hypotheses, like some of the experiments that they showed. And then one interesting aspect about this was about AI safety, right? So if they can do all of this, right, and figure out what parts are being lit up, then maybe you can inspect that internal representation and be able to know, hey, maybe we can detect hallucinations better. We can find deceptive reasoning easier. Right. So it helps us to have a little more patterns that we could use within the security aspects. But what this paper, again, going back to hype, right? This paper, I do not think claims that it's conscious. It has this subjective experiences. It has emotions. I don't think this has anything to do with that. I think it's that is just trying to get eyeballs, right? But I would say check out the paper, and the work, and look at the kind of experiments they run. It is very interesting what they're doing, and it does open up, I think, some new avenues of interpreting how these, Gen AI models really do work, and it can help us with things like jailbreaks or hallucination and so on and so forth.
Marve, you've got the last word. Hot takes on this one as we close out
I
the episode.
know. So, well, you asked if this is a self-hype. Like, there's ton of, I think, controversial parts in this paper, and I think this is by design. Like, they wanted to create this debate, and I first thought this was a great marketing material for Anthropic, right? Everybody's talking about it, but then I realized that Neil Nanda, who runs interpretability at Google DeepMind, he was able to replicate some of these results on open source models. So there is an external validation. So as Aaron was saying, there's something into it, but it's hidden too much under consciousness. And this notion is both interesting and very scary, right? But I think I want to look at the practical side, as Aaron was mentioning. Like, I work with agent builders, right? And I don't want this to be lost under consciousness headlines that the paper has. Like, if you strip all these words and look at what is there, is like this localized, readable, editable internal state, right? So for anyone building agents that take actions on behalf of the users, that's exactly like the handle that you want, right? Like, today we mostly monitor agents by their outputs, like basically judging someone's thinking only by what they say out loud, right? We don't see inside. But there's a tool that sees like what a model represents internally before it acts, or like it's like a real lever, I think, for safety and control, as Aaron was saying. So I think this is huge for real world applications that we're building. So I see a good benefit. I'm looking forward to seeing like what the neuroscience community is gonna take this to from consciousness. But yeah, it's quite interesting.
Well, whether it's consciousness, AGI, or just cost efficiencies in models, you get everything here at MOE. Chris, Marve, Aaron, thanks for joining as always, and that's all the time that we have for today. Thanks for joining all you listeners. If you enjoyed what you heard, you can get us on Apple Podcasts, Spotify, and podcast platforms everywhere. And we'll see you all next week on Mixture of Experts.